Section 4.2, Zeros and Roots of Polynomials. This section mainly has to do with terminology more than anything else. So let's get started. Okay. So what do we mean by zero/roots of polynomials? Okay. So right. So we say x is equal to r is a zero or root is a zero or root of a polynomial. I'll abbreviate that p, or some polynomial p of x if p of r is equal to 0. If I replace this x with r, I get 0. Okay, so this implies, basically, what does this imply? That x is equal to r is a root or 0, of a polynomial if it is a solution to the equation p of x is equal to 0. If I solve this equation and one of the answers becomes x is equal to r, then r is the 0 or the root of the polynomial. Okay, and this terminology is going to be useful for us in the next couple sections, so it's just we need to make sure we understand it. Okay, so let's take a look at how this helps us. Okay, so how we can use it, I'm sorry, not helps us, but how we can use it. So let's say if I just give you a very simple polynomial, p of x is equal to 2x squared minus x minus 3. Okay, and I ask you find the zeros or roots of p of x. Okay, what that basically means, what did we say to do? We need to find the solution to this equation. You take p of x and set it equal to 0. Okay, so let's do that. I take p of x, so this implies we want to solve, let me write that down. We want to solve the equation p of x is equal to 0. That is, I'm sorry, not that is, this implies that x squared minus x minus 3 is equal to 0. This is a quadratic equation with 0 on one side. We can use the quadratic formula, completing the squares, or we can even factor using the AC method. So you can factor on the side using the AC method. So we have 2x divided by 2. We want two numbers. When we multiply, we get 2 times negative 3 is negative 6, and when we add, we get negative 1. So the numbers are negative 3 and positive 2. We can take a 2 out of the second term, and the 2's will cancel, so these are the factors. So we get 2x minus 3 and x plus 1 is equal to 0. Okay, this product is 0. That tells me one of them is 0. So we get 2x minus 3 is 0, x plus 1 is 0. So we get x is equal to 3 halves here, and x is equal to minus 1. So these are the zeros, okay, or roots of p of x. Okay, so we call these two numbers the zeros or roots. Now sometimes what will happen is some of these zeros or roots will repeat themselves. Okay, so let's talk about that. Let me show you with an example first. Okay, so let's say that if I have something like this, if I have p of x is equal to x to the 4th minus 12x plus 12x cubed plus 36x squared. Okay, same question, find the zeros or the roots. So what do? This implies we want to take up p of x and set it equal to 0. So we get x to the 4th minus 12x cubed plus 36x squared is equal to 0. Now, in essence, if you go back and think about it, we solved some linear equations in chapter 2, then we solved quadratic equations, and then we solved some equations that we called miscellaneous, that we could make them quadratic, or we could they had radicals in them or exponents in them and so on. But we never solved problems like this. Anytime you start having equations that have degree higher than 2, the first thing you should try is just by factoring it. Okay, and if that doesn't work, then you want to see if it's almost quadratic and so on, especially if it has 3 terms. Okay, in this case, let's go ahead and factor this. So there's an x squared common, so I get x squared minus 12x plus 36 is equal to 0. Okay, now this has 3 terms, and it's degree 2, so it's really a quadratic. I can factor it on the side, and I'm hoping by now you know how to factor quadratics. If you factor this, you get x minus 6, and x minus 6 is equal to 0. So this product is 0. I have this times this is 0. So what does that tell me? Okay, I have x squared is 0. I get x minus 6 is 0, or x minus 6 is 0. Now technically this x squared is actually 2 things. It's x times x is 0. So it tells me x is 0 and x is 0. This tells me x is 6 and x is 6. So how many solutions did we get, or how many zeros did we find here? I found 2 zeros here and 2 zeros here. Both of these are special because they both repeat. This is 0, 0, 6, 6. So we say that this polynomial p of x has 2 zeros, okay, and the zeros are, or the roots are, x is equal to 0 with multiplicity the multiplicity tells you how many times that 0 repeats, and x is equal to 6 also has multiplicity 2. So both of these have multiplicities 2. So just keep that in mind. Okay, now here comes the big important thing. If you notice in the last 2 examples, when the degree was 2, we found 2 zeros. When the degree was 4, how many zeros did we find? 1, 2, 3, 4. So you can clearly see the number of zeros depends upon the degree of the polynomial. Okay, so that's an important thing to take away from these examples. Alright, so sometimes you have to factor the polynomial, sometimes they might give them to you factored. So let me go ahead and do one last example before I give you some theorems. Let's say if I have a polynomial like this. Okay, I have x minus 1 cubed, x plus 2 squared, and x minus 3. Okay, I have a polynomial like this. It's already factored. So I want to find the zeros. Always remember, when you find the zeros, if you're going to write your answer like this with just writing the zeros once, then you need to specify the multiplicity, or else I could have written the answer this way. The zeros are x is equal to 0, 0, 6, 6. So I could have written it that way. That would be the answer. But if you don't write them explicitly like this, then you want to specify the multiplicity so you know how many times it repeats. So let's find the zeros. So what does that mean? You want to take p of x and set it equal to 0. So I get x minus 1 cubed times x plus 2 squared times x minus 3 is 0. This product is 0. What does that mean? One of them has to be 0. So I get x minus 1 cubed is 0. I have x plus 2 squared is 0. And x minus 3 is 0. Okay. Now x minus 1 cubed is the same thing as x minus 1 times x minus 1 times x minus 1 is 0, because we have 3 of them. and this base is x minus 1, so you multiply it 3 times. Each one gives you what? X minus 1 is 0, so we get x is 1. So you get x is 1, you get x is 1. Over here we get x plus 2 is 0, and x plus 2 is 0 because of the exponent of 2. So we get x is equal to negative 2, x is equal to negative 2. And out here we get 3. So if you take a look at it, okay, my zeros are what? You can write it explicitly this way. My zeros are x is equal to 1, 1, 1, negative 2, negative 2, and 3. Or you could write it this way. X is equal to 1 with multiplicity 3, with negative 2 with multiplicity 2, and then just 3. So you can write it either way. Okay, but you can see how sometimes zeros tend to repeat, and don't forget to include them that many times. By the way, if you were to expand this, if you were to multiply this guy, you know, if you take x minus 3 cubed, what is that? X minus 1 times x minus 1 times x minus 1, or we could use the binomial cubic formula. Okay, but anyway, the highest power of x here is x cubed, and then there'll be some more terms. Out here the highest power of x is x squared with some more terms, and then x minus 3. So if you multiply x cubed by x squared, we get x to the 5th. X to the 5th by x, we get x to the 6th. That's the degree of this polynomial. So the degree of this polynomial is 6 because the highest power of x is 6. So we should have had 6 zeros. Let's see if we had them. 1, 2, 3, 4, 5, 6. So we had 6 zeros. Okay. So that brings us to the main theorem of this section. And this is technically considered the main theorem in algebra. That's why it's called the fundamental theorem of algebra. And there are different variations from there, but it basically states that if p of x is a polynomial of degree n, is a polynomial of degree n, then p of x has exactly n zeros, okay, some of which may repeat. That means they have some multiplicity, and you saw that. So this is an important theorem for algebra. That's why it's called the fundamental theorem of algebra. This theorem was proven by Carl Gauss when he was really young, so the credit goes to him for proving this theorem. Okay, alright. So now from this point onwards, anytime you're given a polynomial equation is equal to 0, you know how many zeros you're looking for. Okay, for that polynomial. Okay. Alright, so then we have the factor theorem. This is called the factor theorem. This is an important thing which states that if x is equal to r is a 0 of p of x, this polynomial, then x minus r is a factor of p of x. Okay, and I'll give you an example of that in a second. So if x is equal to r is a 0, then x minus r is a factor of p of x. Okay, and the other variation of this is if x minus r is a factor of p of x, then x is equal to r is a 0 of p of x, the opposite direction of that. Okay, so let me show you an example by what I mean. Okay, like for example, let's say we have p of x is equal to, I'll just start with a simple example that we already know works, but let's assume it doesn't. This is a 2, 15. Okay, I want to find the zeros. So what do? I take my polynomial, and actually let me start this way. Let me say I tell you that find the factors if x is equal to 5 and -3 are zeros of the polynomial p of x. So we already know the zeros. Can I find the factors? How do I find the factors? Look at that. If this is my 0, okay, then the factors are what? All you do is take this r and move it to the other side. If it's a positive r, it'll become negative. If it's a negative r, it'll become positive. Then it becomes this. Okay, so if x is equal to 5 is a 0, then the factor is what? The factor must be x minus 5. You just move the 5 over. If x is equal to -3 is a 0, then the factor must be what? X plus 3. You move the -3 to the other side. And that's what that theorem tells you. That means a factor of this polynomial are x minus 5 and x plus 3. Okay, and you can see that if I were to factor this polynomial, this is a simple polynomial that I can factor easily. When you factor it, you get x minus 5 and x plus 3. So those are my factors. Okay. So once you know the zeros, you can tell a lot about the polynomial. You can tell its factors. Okay, and that's pretty much the main thing in that section to remember. The zeros of the polynomial and what they mean. There are other things that are in that section in the notes, but if you can remember the things that we just covered, there should be plenty. Okay.